There we are. Okay, so hi everybody, thank you for coming on. As said, I'm going to talk about the Future Engineers project, which is a project that we ran at Science Oxford about a month ago. So it was a programming and robotics holiday camp for kids, and we officially we call it the Future Engineers project, but it was also referred to as Robot Camp to most of the kids, and occasionally Tinker, Taker, I can never say that right. My boss had just watched a lot of spy movies when we put the grant in, so we ended up with lots of different titles. That was quite cool. So it was funded by the IET and the IMechE and their engineering education grant scheme, which was really great. So so who are we? Science Oxford is an educational and outreach charity based in Oxford, obviously, and we do a lot of science outreach, we do a lot of tech outreach, and there are two of us here at PyCon this week, me, obviously, and my colleague Noelle, who's sat at the front. Some of you will have met her. So our sort of focus is the tech side of things. So I supposedly mostly work with in computing, and Noelle works on the maker side of things, so we work really closely together on various different projects. So Science Oxford, we work with children, young people and adults. We run STEM workshops in all sorts of different places, in schools, with family groups, with partners at museums and arts groups. We run Saturday clubs, and education and engagement is our purpose. So we're not going places to teach the computing curriculum, we're trying to excite young people about technology and about computing and get them thinking about it as something that is something cool to do. So the point of this camp was to reach young people living in areas of high socio-economic deprivation in Oxford who might not consider engineering as a career for them. So to do this, we spent a week with the same group of kids, and we split the week. Each day was split into two halves. So each morning was spent doing a technical workshop. So we did programming with the BBC microbits on the first day, and we did some computer-aided design on the second day. We did some soldering on the third day, and then they built their robots. They were sort of something like this. I came very prepared. I have lots of examples, so do come and look at worksheets and stuff at the end if you're interested. So we did some soldering. So the aim was they would build their own robot from a kit. They would program it themselves. They would add some sensors, and it would end up looking something a bit like this. So this one is missing its brain. The microbit is supposed to go like there, but it's got a couple of micro switches on the front, and they designed that chassis themselves, and we got it laser cut for them, and they built it all themselves. So it was really cool. So that was the technical side of it, but we also tried to run the workshops in such a way to help promote some more sort of soft skills as well, so encourage some team working and problem solving and resilience. Lots of things went wrong, and we had to help them to overcome their problems and not give up, and yeah, it was really great. So the second half of the session, the second half of the purpose was to engage them in the thought of engineering as a career, make them think that it could be a career for them, and get some idea of the range of different options that are out there. So we had 30 really great volunteers who came to the workshops, who we recruited from a wide variety of sources. We had some from the IET, we had some who regularly volunteer with us, some STEM ambassadors, someone that I met at a Code Club meetup. We had people from all over, which meant we could get a really good range of people from different backgrounds with different careers, just to show the kids that you didn't have to be a certain type of person to be an engineer. So we also took them on some workplace visits. These happened in the afternoon. So we went to a company called Street Drone, who builds self-driving cars. So they got to meet some of their engineers there. We took them to Oxford Brookes University, to their robotics lab, where they met some of their current master's students and saw their in-progress projects. And we took them to our makerspace in the centre of Oxford to laser cut their things for them and show them 3D printers, that kind of thing. And we took them to the Rutherford Appleton laboratory, where they, as well as seeing a massive research lab, got to have a go at controlling some robot arms that are used in radioactive environments to do maintenance. So that was really good fun. I think this is off. Am I talking loud enough for the people at the back? Perfect. I'll just keep going, it's fine. I don't like microphones anyway. So the final sort of objective of the week was to provide continued learning. We didn't want to do some programming with them, and then take their microbits off them and be like, all right, see you later. We didn't want them to build all this stuff and then never have access to it again. So we were really lucky that the Microbit Foundation donated microbits for all of the young people to take home. The grant paid for the robot kits, so they took their finished robot home. We provided them all with a USB stick full of project resources and links to different places. We took them on a trip to the local library's makerspace so they could see the facilities there that they can go and access for free. And all the software we used was free and easily accessible, so they could continue with their CAD, continue with their programming at home, at school, in the library, anywhere they wanted to. So why use a robotics camp to teach programming? One reason was completely selfish. It is the sort of camp I really wish I could have gone to when I was a teenager. And so I just sort of prepared this week going, oh, wouldn't that be awesome? I wish I could have done that. So yeah, it was very selfish really. But the other half of it is something we were talking about in our workshop earlier, that we don't really believe that programming, when you're running these kind of workshops, programming shouldn't be the end goal. Programming is the tool you use to complete a problem. So we give the young people a challenge to complete, a challenge to solve, and show them how to use programming to solve that. So they're invested in the problem, they want to solve it because they want their robot to zoom around. They want to be able to show it off to their family at the end of the week and say, look, I made this move. So it's a really good cross-curricular project that gets them excited about the sorts of things you can do with a bit of programming knowledge. So finding funding was our first issue. I'm sure other people have had the same problems. We applied for a grant and didn't get it, which was really upsetting. So the key for us was finding a grant that had a really good fit. The engineering education grant scheme was perfect for us. We didn't have to mould the projects to fit what they wanted for the grant because it already kind of fit those criteria anyway. So if you're looking for funding, that's kind of the key. Try and find something that fits with your project. And also reaching out to contacts. So we got in touch with the Microbit Foundation, we got in touch with local businesses, a local school, Abingdon School, were kind enough to loan us their minibus so we could drive the participants to the activities. We didn't get anything from parents, but in other things that I've done with schools, the schools have known parents of their kids have worked in certain places or have got certain backgrounds, and sort of recruiting all those people and getting them involved is really good for trying to get funding. And I reached out on Twitter and got loads of cool stickers and really nice stuff to just give out to the kids to make the week extra special. So that sort of thing is great. So after we managed to get the funding, then the next step was planning and preparing for the week itself. I had assumed that the main proportion of the time would be spent on designing the workshops, the ones that weren't based on something we'd done in the past, and testing the activities. But that was definitely not the case. We had loads of volunteers, which was amazing, and we were so lucky, and it really made the camp. But talking to all those volunteers, recruiting those volunteers, all took a lot of time. Organising the workplace visits. It turned out that some of the visits that I had assumed we would be able to go on, because we had contacts in those places and we've worked with them before, the age group we were targeting were too young to visit the sites. We had young people aged 11 to 15, and a lot of workplaces don't allow people on site until they're 14. So we had to try and find new places to visit and work with people that we'd never worked with before, so there wasn't that shared understanding at the beginning. So that added to the time. Buying the equipment, I thought, oh, I'll save all this budget, I'll order everything from China, it's going to be fine. And yeah, some things never turned up, some things turned up 2 days before the camp. Yeah, it was crazy. Testing the equipment, testing everything that we had planned on the laptops that we had available, finding out that some things didn't work and having to find laptops. Luckily, we ran this in the summer holidays, so a lot of my colleagues were on holiday, so I stole everyone's laptops from the office. It was great. Exciting extras, making these incredible project boxes that Noelle so beautifully designed, and collecting things like stickers, all of that stuff. Again, made the camp amazing, but took a lot more time than we were expecting. GDPR, the dreaded word, working out photography permissions, see if we could get pictures to prove how amazing this camp was, dealing with the parents, contacting them, reassuring them that we weren't going to hurt their children. It all took a lot of time. So what would I recommend if you were trying to prepare something like this yourself? Work with organisations who already work with volunteers. Go to the STEM ambassador and say, I need some help. Don't try and do it all yourself. Don't necessarily try and buy everything off eBay. Do just spend a bit of money because sometimes it's not worth the stress. Tailor your workshops to the equipment you already have. I really, really wanted to do some computer-aided design. And we didn't have the ability to do that, so it ended up taking a long time to get that working. I think it was worth it because it made the camp what it was, but looking back, there's things I'd definitely do differently. And similar to that, prioritising, deciding which of these things are worth it, what you really should spend your time on. So the lessons that we learned from the camp. The lessons we learned on Monday was that the project boxes were a massive success. I broke 2 of those before the camp by knocking them off the laser cutter, and I thought there was no way they would survive the week. But they were given them as incomplete boxes, and they glued them together, and they stuck their names on it, and then we gave them pens and pencils and rulers and their micro bits, and they kept it all in the box. And because they had put that box together themselves, and it was their box, and all of their things were in the box, everything stayed together, and it was amazing. I'm not sure that we lost any pens. No one asked me for a pen all week. It was wonderful. So that was definitely worth the time that we put into that. Well, sorry, Noelle. Noelle put most of the time in. I think it was worth it. We had a few technical issues again with the programming section, which was probably because I hadn't tested things using the Wi-Fi in the venue we were using. We were in a community centre, and I hadn't tested. I hadn't tested the Wi-Fi connection. We also installed the new Mu editor a day after it had been released, and then didn't test it, and it didn't run on half of our laptops. There was various things that we did that meant that they didn't get as much programming done on Monday as I would have liked. We had planned for them to have an introduction to the microbit session, learn how to make their name scroll across the screen and that sort of thing, and then take a set of pre-built robots that we've got like this and have a go at programming them and making them move around so they could just get a feel for what sort of the end goal was. But most of that didn't actually happen on time, unfortunately. The other thing was I severely underestimated how long it would take to get 13 young people onto a minibus after they have eaten their lunch. They eat their lunch in 30 seconds flat and then just sit there. It's like, we're going to the minibus. Oh, okay. Oh, they haven't gone yet, so I'm just going to sit back down. Oh, we were late to every single visit all week. It was ridiculous. The other thing was that we realised they weren't really talking to each other that much on Monday. They didn't know each other, they'd all come from different schools, but some had come as pairs of siblings, some had come as friends, so they were only talking to their own group. So we had a little chat at the end of the first session and decided that the next day we would come in on Tuesday for the CAD session, and we would use the project boxes again with their names on and sit them in groups based on their age. And I also asked them to make a playlist, got them to talk on their tables and get them talking to each other. And I think that really worked. By the end of the week, they were much happier with each other. The Tinkercad was fantastic. Has anyone used Tinkercad before? Oh, it's so good. I'd never used it before this session, but they've got a really nice set of tutorials that you can run through and that just get you up and running really quickly. You can drag and drop shapes directly onto the workplace and then have something to laser cut or 3D print. They've got stars and hearts. They've even got like countries. You can drag the UK or an American state onto your project. It's incredible. So Tinkercad was wonderful and they really, really liked it, I think. Then we gave them this sort of example robot chassis and asked them to make their own. I was expecting them all to want to make some crazy shape and put all the holes for the motors in the right place, but they weren't actually that interested in that. They wanted to put their name on it, they wanted to stick a little bumper on the back. So I think next year, or if we run it again hopefully, give them some more examples. So say, here's one shaped like this weird thing, here's a different one shaped like this, and give them a few more examples about what sorts of things they can make, instead of expecting them to just, I think I put them on the spot, I think, and said just make something, and they needed a little bit more guidance. So Wednesday was the soldering and building day. I was very, very optimistic about how quickly young people would be able to solder something together for the first time. They made a little LED torch monster thing like this. So it was 2 LEDs, a couple of resistors, and a switch. And we had lots of volunteers. We were really lucky that day. We had, I think, 1 volunteer per 2 or 3 young people at a soldering iron. But it took them, I sort of budgeted for the day, they get an hour to practice and then we'll move on. But that didn't work. So by the time we got to the building section, they stripped their wires and soldered them to the motors, but they didn't get any further with the robot building, and I'd planned for it to be finished, so that was quite a revelation to me. There was something else I was going to say on this day, and I've already forgotten what it was. About the soldering, it did take them a long time, but they loved it. They weren't getting frustrated. They didn't say, oh, I don't want to finish this, I'm bored. They were desperate to come back in and finish it, and they were really worried that we were going to take the soldering irons off them and say, no, you can't finish it. They were really excited, so that was wonderful. And the laser cutting. Poor Noelle was stuck in the laser cutter room for ages. Their designs took a lot more tweaking than I was expecting, I think. I'd sort of assumed that we could just download it from Tinkercad, so experience with Tinkercad is helpful, so that's something else to bear in mind. So Thursday was supposed to be our nice full day of programming. However, we hadn't finished building robots, so the plan for Thursday had been, you have an almost completed robot, so let's discuss how it's going to work. We were going to have demos of the different kinds of sensors. We had line following as an option, we had little bumper switches, and we had radio control. So we were going to demonstrate those, discuss the pros and cons, talk a bit about the logic of how it worked, how when one switch is pushed, it needs to know which direction to turn, and to think about how that was all working. And discuss how to use the functions to make it go. So I'd written that part for them. They were going to control the switches. But because they then had to spend the day building, they all got to that stage at different times, and I hadn't quite prepared enough, so it was all a little bit chaotic. So that evening, I wrote some more example code, so when they came in on Friday, they could make their robot go forwards until a switch was hit, and then it would stop. So they just had to worry about left or right. Because I made the decision that the point of this camp was to inspire them and to get them excited about computing and robotics. It wasn't to teach them what every line of code meant. So I didn't want them to be really frustrated on Friday when their parents turned up that they hadn't got their robot doing anything. So again, I would have had, if we did this again, I'd need to make the decision as to what was the most important thing for the week itself, what I thought was the most important thing at the time. But yes, we prepared some more extensive example code for them and drew some ridiculously terrible wiring diagrams in Microsoft Word to try and explain where the switches were supposed to go. So that was done very hurriedly, and we'll need an update if we run it again. So lessons from Friday. It was great. We had a really great week, I think. They came in on Friday. A couple of them had started their sensors, but most of them hadn't. They just had a little think about how they would work. So we grouped them on tables based on those who'd picked one sensor, those who picked another sensor, those who hadn't finished building yet, so that we could sit with them and try and help them to work it out. They were all different stages, but they were all really keen to get it finished. None of them got bored. We prepared all sorts of extra things for them to do, assuming that once they'd finished, they'd want something else to do. But they were happy to help each other and help each other finish their code. They were happy to just zoom their robots around the maze and just have a go, so that was really lovely. So these are just a few examples of the things they made. The one on the left was based on Totoro from the Studio Ghibli film. Which one is it? It's not Halloween.
My Neighbor Totoro.
My Neighbor Totoro. And this one here had a little duck face, so she designed that herself in Tinkercad, and we 3D printed that for her. This one used the micro switches. None of them were interested in the line following, which I was quite surprised by. I thought it was quite interesting as to what they responded to, and I think having some more examples and being able to sit with them and discuss the pros and cons as a group might have helped them to understand a bit more about what each one did and why they might want to use them. This one's one of my favourites. When the parents arrived, this little boy had coded it with a radio control, so he was driving biscuits around to everyone, and then he put a cup of tea on it and drove it around. I assumed it was an empty cup of tea and then went to investigate. It was not an empty cup of tea, but he was so careful with driving it. It was wonderful. And it was great. We had some volunteers come. We had a few people from the IET turn up, and it was really nice for the young people to be able to see that people were interested in what they had done. Not only their own parents, but parents of the other people there, these adults they'd never met before, coming in from businesses to go, oh, that's interesting, tell me how you made that. So I think that was really valuable. So did we meet our aims? Yes, we saw a change in attitude. We did an evaluation survey at the beginning and at the end, and we did see a difference in, I can't quite remember what questions we asked, but it was things like, do I think that I have the ability to learn the skills to become an engineer? Do I think engineering is a career that's for someone like me? Those kind of questions. And there was a shift in attitudes. I do have the actual evaluation data, but I couldn't be bothered to make a graph, so if you're interested, you can ask me, otherwise take my word for it. Were they excited about technology? We could see on the Friday that they were. They were so happy to show it off. Once they had completed one sensor, a couple of them said, oh, but I really wanted to have a go at the radio control, and so they just sat there and carried on coding while their parents arrived to try and get their second sensor working. They really, really were excited. And did they learn some technical skills? They did. Obviously, we only had them for a week, and we were only doing the skills for sort of half a day. But compared to when they first picked up a soldering iron on Wednesday morning to when we left them, not completely unsupervised, but left them to themselves to solder wires to motors, they were confident enough to be able to do that for themselves. And they picked up the Python fairly quickly. We stopped having to go around saying, oh, if you remember to indent that, if you remember to indent that. They definitely did improve their technical skills over the week, so that was great. So there are obviously things that I would change. I'm a little worried that I'm going to run out of time. But so as I said, we didn't get as much programming done as I wanted. To say it was supposed to be a programming of robotics week. And so would I cut out, say, the soldering, or would I cut out, say, the CAD portion to be able to spend more time on the programming? Yeah, I'm really not sure, because I think the reason that they were so keen to finish programming their robot at the end was because it was theirs. It was their robot. The first girl who finished her robot, I took her over to the sensors and said, so these are your options. You can do this, you can do this, you can do this. I could tell she wasn't listening to me, so I just looked at her and she just picked up her robot and went, I built this, I made this. And it was really amazing. So honestly, I know that I'm at a programming conference, but honestly, I think the programming was possibly the least important part of the actual week. So I would definitely make how we ran the workshops more efficient so that they got some more programming in, but I don't think I would change anything that significantly. So next steps, we are hoping to maybe run this again, or to run it with some secondary schools in the area, to work with the teachers to run it as their DT curriculum. So if any of you are a DT teacher or work with DT teachers, I'd be really interested in picking your brains about how that might work in a school. Yeah, so in my 30 seconds left, any questions? Oh, all the resources are on GitHub. They're not lesson plans or anything, but they exist. So the end. Thank you. Thank you very much.